Hey guys, so here's the notes for our lesson 12. We're going to be talking about how to use a graphing calculator to analyze polynomials. So let's first talk about turning points of a polynomial. So basically a turning point, so how we figure out how many there are is if our degree is n, then the graph has at most n minus 1 turning points. So what this means is that like if we had a degree of 3, then they would have at most 2 turning points because I would do 3 minus 1 to give me that. Okay. Now out these turning points, we can talk about our max and mins. We have what is called local max and mins. So basically they occur at the y of the turning point. So kind of let me give you like an example or just a little thing of what we're talking about here. So let's say I had this graph. I go boop, boop, boop. Okay, so basically here, our point right here and our point right here, this would be a local min, and it is a turning point. Same thing here. This would be what is a local max. So remember, max is at the top, but it is also a turning point. So basically, a turning point is when the graph goes from increasing to decreasing, or vice versa, decreasing to increasing. Okay. Okay, so now let's talk about, on that point, increasing and decreasing intervals. Okay. So basically, we want to figure out when on an interval, and we're going to use x values here. Basically, our graph will increase or decrease. So the function, let's talk about increase. If the y values are increasing, so that makes sense, right? The graph is increasing when the y values are increasing as the x values increase as well, okay? Because remember, in this case, we are reading a graph left to right, so our x values should always increase. Now, function is decreasing if the y values are decreasing. Now, in this case, as the x values increase as well. Because remember, the idea is that we are going left to right on our graph. So if I kind of scroll up, so here, though, like right here, this would be considered increasing. So our y values are getting bigger, but so are the x's because they're becoming more positive here. Now from this spot here, we're decreasing because the y values are getting smaller. They're decreasing. But x is still increasing because as we kind of look through a graph, we go from left to right, so from smallest to biggest, okay? Now, the thing is, a graph, whoops, there we go. It's like a function is neither increasing nor decreasing at the turning points. So when we write our interval here, we're going to use our x values, okay? And so when we do examples like this, when we actually write the interval, you're going to see, notice that we use parentheses instead of brackets, so we're writing in that interval notation. It's because when we're at those turning points, as we said, it's neither increasing nor decreasing at that point. So that point won't be included, but everything before it or after it will. Okay, make sure you watch the next part. There, we're going to be talking about how to use the graphing calculator to find the turning points, which are your local max and mins, and then how to find the x-intercepts.